Howdy, students. In the last video, we talked about the massive amount of climate-safe energy we have to build over the next few decades, about 1 gigawatt per day, to reach our goal of stabilizing the atmosphere at a level that avoids dangerous climate change. 1 gigawatt per day seems like a lot, and it is, but it's entirely within our abilities. But you can't simply say, let's build climate-safe energy. Emissions are mostly determined by the decisions made by a large number of individual actors throughout the world's economy. These individual actors are making decisions that are in their best interest, but because of externality, their best interests are not always the best interests of society. So how do we solve the problem? The single most important policy is a price on carbon. We went over in chapters 11 and 12 why this is so important. It makes emitters pay the full cost of their actions. It makes them internalize the externality. Second, although a price on carbon is crucial, there are some economic sectors where great progress can be made rapidly, but where expected progress with just a price on carbon will be too slow. For these sectors, conventional regulation should be considered. An example is fuel efficiency for cars. A carbon tax might only change the price of gas by, say, 25 cents a gallon, which might not be enough to convince people to buy more fuel-efficient cars. In this case, the government can require that automakers improve fuel efficiency of their fleet. Third, money must be spent on research and development of new technologies. Although it may be possible to solve the climate problem with existing technology, innovation of new technology can ease the transition as well as reduce the ultimate cost of stabilizing the climate. Of particular interest would be a breakthrough in battery energy technology. This would help alleviate the intermittency of renewable energy. For example, solar energy generated during the day could be stored and then fed into the grid at night. Another welcome breakthrough would be a breakthrough in removing carbon from the atmosphere, which would greatly reduce the pressure for very rapid emissions cuts. Fourth, prepare to adapt to climate change. Even under the most optimistic scenarios, warming will continue for decades. To the extent that this warming cannot be avoided, we must adapt to it. Thus, adaptation must necessarily be part of our response to climate change. It is cheapest to adapt in advance, so we should incorporate the reality of climate change into all plans for the future. This is particularly true for investments in long-lived infrastructure. When we build a road, airport, power plant, or the like, we have to make sure that it's resilient to expected changes in the climate. This will also help harden our society against the natural variability of the climate system. Fifth, we need to prepare for what to do in the worst case. If the world cannot get its act together and the uncertainties all fall on the bad end of the spectrum, then geoengineering is our last resort. For example, as we talked about earlier, if we cannot reduce emissions fast enough, then the climate will overshoot whatever target we're picking. If we judge even a temporary overshoot to be too much, then we can cut off the top of the overshoot with solar radiation management geoengineering, which we talked about in chapter 11. Climate change can only be solved if all major emitters contribute to the reduction. But there is no world government to implement a policy that covers everyone, so it will require a negotiated international agreement among all of the major emitters. Since the Framework Convention in 1992, the dominant assumption has been that climate action would mostly take place through international negotiation, which results in all countries agreeing to participate. This reflects the issue's global scale and the belief that mitigation is fundamentally a global collective action problem in which states are unwilling to take costly actions unless most others do the same. This was the approach taken with the Kyoto Protocol. The lack of success of the Kyoto Protocol and years trying to negotiate a follow-on agreement convinced many people that the approach is flawed. In the Paris Agreement, countries simply committed to what they felt they could accomplish. In response, many countries proposed surprisingly ambitious cuts. So the assumption that countries would only reduce emissions if other countries did seems to have been wrong. There are many reasons for this. Many actions that reduce greenhouse gas emissions also bring local co-benefits in energy security, air quality, or public health. For example, air pollution from burning coal kills millions of people each year, including tens of thousands in the United States. So reducing coal consumption can bring large health benefits. It seems likely that this is the path of the future. There will be no initial worldwide agreement to reduce emissions, but rather, leading action will remain concentrated in individual countries, groups of countries like the European Union, or even individual U.S. states like California. This doesn't mean, of course, that we don't eventually need to get to an international agreement. We absolutely need everyone to eventually contribute. But starting with a coalition of the willing avoids a lot of the problems that have arisen in previous negotiations, such as disputes over the relative contribution from countries at different levels of development, and it also avoids the stalling and delaying tactics of big energy producers like Saudi Arabia that really don't want an agreement. In response to any policy suggestion, you should expect to hear the tobacco strategy. The science is uncertain, and solving this problem will be too expensive. You've just spent a semester learning the science of climate change, and at this point, you should recognize that much of what is disputed in the public debate is actually known quite well. We know the climate is warming, we know that humans are primarily to blame, and we know that future warming could be very, very large and its impact severe. The argument that it's too expensive is another poor argument. In reality, we don't know how expensive solving the problem will be, because it depends on things like the rate of innovation. But we do know that the cost of compliance of past environmental issues has ended up being much, much cheaper than even the most optimistic estimates beforehand. For example, before regulations to phase out ozone-depleting CFCs were passed in the 1980s, some advocates predicted that those regulations would cause an economic apocalypse, with people in the developed world having to get rid of their air conditioners and millions in the developing world dying because of a lack of food refrigeration. It turned out that innovation in response to the regulation led to the development of substitutes for the ozone-depleting chemicals so cheap that when the new chemicals replaced the older ones, virtually no one noticed. Given that renewables are already competitive with fossil fuels in many markets, it seems quite likely that once a price is put on carbon emissions, additional innovation by the private sector will produce more breakthrough technologies that allow us to make reductions in emissions cheaply and with minimal economic disruption. In the end, there are no good arguments I've heard to not take aggressive action on climate change. In the last video, we'll summarize the chapter and the semester. And now, your moment of dog.